Ladies and gentlemen.
Master Payne.
All the way from Wallingford, please welcome
Master Payne!
Good afternoon, everyone. Thank you. I'm so glad you could make it, as I've brought something rather interesting this year, which I know you've never seen before, as I haven't had this trick out in a long time. In fact, the last time I did it, I think, was during my college days. A little slow on the uptake. All right. It's actually a presentation I developed for a high school science fair project to illustrate some of the basic concepts of quantum mechanics. I just lost half the audience. Now, as we all know, the science of quantum was created 87 years ago in a small public house just outside Stuttgart. There, the famed Austrian physicist, Professor Erwin Schrödinger, first postulated that you could not measure nor know the outcome of any event until its waveform collapsed. Obviously, they sat the engineers on that side of the theater. Until that point in time, the event must be said to exist in a state of quantum flux, being a combination of all possible outcomes. Unfortunately, Professor Schrödinger's colleagues were all a little too deep in their cups and couldn't grasp the finer points of this idea and started him quite blankly. Much the way most of you are doing to me right now, except that guy. So, in order to explain his theory more succinctly, he devised what has become known as the Schrödinger's cat paradox, where you have a cat, a box, and a diabolically clever little device, which is designed to kill the cat when an atomic particle decays to a predetermined state. Now, since quantum cannot tell us the exact time the particle will decay sufficiently to trigger said device, we can thus never know the exact status of the cat. So the cat must be said to exist in a state of quantum flux, being both alive and dead simultaneously. It is this theory I wish to illustrate for you this afternoon. Not with a cat, not with a cat, because it really didn't work out well in rehearsal. But in fact, these two cylinders, which in keeping with our public house theme, contain a glass and a bottle. Now, since I don't know which cylinder contains what object, the contents of these tubes right now are in a state of quantum flux, and I can honestly tell you that each one contains a bottle and a glass simultaneously, and will continue to do so until I cause their waveforms to collapse by lifting the cylinders. Thus, we can see that the glass is here and the bottle here. Isn't science fun? But not very entertaining. For that, we need to rely on the Heisenberg uncertainty principle, which states that by simply observing an event, you change it. So, since we have observed the glass here and the bottle here, that means they change. And now the bottle is here and the glass is here. This I will verify. Yep. However, since I have observed them in their changed state, that means they revert back to their original position with the glass over here and the bottle here. I recognize facetious applause when I hear it. And I sense skepticism in the room, which is good. Science is built on a foundation of healthy skepticism. And since this is science and not philosophy, you rely on empirical proof. And thus, you wish to observe firsthand the effect. So watch. Since we've observed the glass here and the bottle here, that means they change. And now the glass is here and the bottle here. But since we've observed them in that changed state, that means they revert back to their original positions with the glass here and the bottle here. This will continue to occur every time we observe them until we stop looking. This can be demonstrated by covering them up just like so. And if everyone looks up over here, way up here, don't look at the tube, look up over here, you will actually see that they don't move at all, but remain in their original position. Many people would look on this as a mistake. I, however, like to look at it as a grand illustration of the Schwarzschild space-time continuum equation. What you mistakenly believe to be two different bottles here at the same time are in fact two of the same bottle, but here from different times. Regardless, I have too many bottles, and thus I will remove them from the equation, which now allows me to illustrate one of the finer points of Einstein's theory of relativity. From your relative position, it looks like I am in possession of two glasses, one underneath each cylinder. However, from my relative position, I know this to be impossible, because if I was to have two glasses, one under each cylinder, this would violate one of the basic precepts of Newtonian physics, which state that two objects cannot occupy the same space at the same time. Thus, if I have a glass under this cylinder, it is impossible for there to be a glass underneath this cylinder, as that's where the bottle is. The only way that there could be a glass underneath this cylinder is by removing the bottle, thus creating a void or a vacuum, which we know nature abhors, which then would fill it with a glass, leaving this cylinder with plenty of room for the bottle. So, let us recap. I first illustrated the Schrödinger's cat paradox by having the waveform collapse around the glass and a bottle. I then demonstrated the Heisenberg uncertainty principle by having that glass and the bottle change places. Oh, you can applaud, that's perfectly acceptable. I then showed you the Schwarzschild space-time continuum equation by having two of the same bottle appear here, but from different times. Now, as I said, this was a high school science fair project, and you're probably curious as to how I did. Unfortunately, not terribly well. At least until I pointed out to one of the judges, who was also the high school football coach, that I had 6 bottles of beer here, of which I was far too young to imbibe, but did he know anyone who might be interested? Needless to say, my score went up quite a lot. Unfortunately for him, since this was all the same bottle of beer, he had to pour and drink it simultaneously. The rest of the judges, unfortunately, tastes were a little more sophisticated. So, if anyone here is considering entering a high school science fair project of their very own, I suggest maintaining a well-stocked bar with a wide and diverse assortment of various and sundry libations, such as wines, or liqueurs, cordials. Cordials are always a good selection, as is an assortment of imported beers, as you never know exactly where one's taste would lie. And that, ladies and gentlemen, is how I won first place. Thank you! And